Good morning and welcome, everybody. Happy Earth Day and happy EV Day. We are here with all of you live to have this fantastic event. We have amazing presenters for the entire day, but the real star of the show today is going to be you and your students. So we can't wait to see what you guys design and come up with. I hope that your engines are ready and ready to roll. Milton Davis is here to start us off with the introduction for our amazing EV Day. Milton, you want to take it away?
Oh, thank you for that awesome handoff. And hey, as Monica said, happy Earth Day. Look at that. I mean, what better lab to work on today than the electric vehicle lab? I mean, we're talking about sustainable energy. This is my favorite electric vehicle. It's a Lucid Air. You talk about sustainment, 500 miles without a charge. Look at that car. It's beautiful. They call it the Dream Edition, and that sure is my dream. And today is the ET takeover. Engineering tomorrow is everywhere. We got Joanna Caudle, she's out at Ramit Gosh, Jackson Reed. We got Eric hanging out with Liz Cabin out at Maria Regina. And we got my buddy Jerry kicking back with Maria Gomez at Salacian High School. We are taking over today at a theater near you. Hey, the next special lab, we may be at your school. So you got call Megan, call Constance. Let's see if we can make this thing happen. What are we talking about today? We're talking about electric vehicles and it's sustainable energy, right? I love vehicles, right? Vehicles have just absolutely changed the game, but we need energy to sustain them. Why is that important? Well, one reason this is important, could you imagine life without transportation? I mean, your iPhone, what are you going to do without an iPhone? All these parts in an iPhone come together because of vehicles and transportation. Going on a nice vacation. I mean, my family and I, we just went to Disney. We were checking out Mickey Mouse and everybody out there, but we couldn't go there without flying on the plane or taking a car. Transportation vehicles are important. But even more important, just this awesome technology of medicine that has been able to heal and sustain us. Imagine you're in a country where you don't have access to that. You need it transported. I mean, if you have a serious condition and you're in an emergency and you need medevac support, that's transportation. Vehicles are important to that. Clean water, transportation. What I love, space, right? We can't investigate this awesome universe without vehicles, without these vehicles. And what I do and what I love, we can't do it without a vehicle. This is a vehicle. This is my satellite design problem that I love working on, every single day. It's a vehicle though that allows us to investigate things like the moons and the stars and other galaxies, right? You're going to be developing electric vehicle as well to solve a problem, but we can't do it without vehicles. But even though we have these great vehicles that NASA is developing and develop that even allow us to go, the speed of sound on this earth, if we don't have a sustainable way of producing and making the energy for all the different vehicles we have, if we don't have a sustainable way of enabling transportation, it's going to be for naught. This huge technology that we have will be for naught. And I agree with whoever just shouted out. It's a challenge for me as well. So, well, I'm so happy that Kelsey Farr, who is going to be our guest speaker today, developed this electric vehicle lab. It's a great lab. It also was developed by Dr. Einstein and Caroline and Julian, you know, that we can develop a vehicle using
I can't hear.
sustainable energy sources. That's what we're doing today. But before I get into the lab, I would love to engage with you all just a little bit. If you could go to this site, slido.com, and type in those numbers 297. If you catch that, I'm trying to set it up here now again 297-8156. It's going to give me the chance to engage with you all just a little bit this morning. Thank you so much, Monica. I want to know, what is your dream car? You already saw the Lucid Air. Obviously, that's my dream car. I mean, it's that dream edition is just off the chain, just can't beat it. Beautiful car, powerful car. What's your dream car? If you had to choose between a Bugatti, or a Land Rover, or a Lambo, or that Honda Civic, a little economical, the Nissan GTR, right? A Jeep. Oh, the Bugatti is coming in strong. That's an expensive car. You better get an engineering degree. You need to be an engineering tech CEO. if you're gonna cop a Bugatti. Excellent. All right, this is good. Great, 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 great. Great engagement. Great engagement. I see Tesla's up there too. That means people are appreciating electric vehicles. Excellent. Nice. Let me give you a little bit of the history. We talked about where we are. You saw the Bugatti, you saw the Lambo, but how did we get here? It all started with an electric motor. People believe that gas powered cars, we're going to call them internal combustion engines. People believe those were the first vehicles, but they weren't. Electric vehicles were first. Someone noticed that when you have magnets and you place them in an electric field, you conduct electricity, place them in an electric field, you can call and you alternate that current. You can cause a motor to spin and you can use that torque to move a vehicle. But the problem was, even though this Hungarian man named Jetlik came up with this awesome device in 828, the issue was we didn't have enough power. It wasn't enough battery power to sustain that vehicle travel. So gas powered cars took over, and that's what we have today. But things have changed. Electric vehicles are on the rise, a more sustainable approach towards transportation. So we got to compare those two. You're going to compare electric vehicles to these gas powered cars. So let's think about electric vehicles. What do you think are some advantages? What are some advantages of electric vehicles? What do you think? You can type it in the Zoom chat if you're in Zoom. If you've got a classroom, that's great. If not, you can type it right here. What do you think are some advantages of electric vehicles? What's good about electric vehicles? Why are they a little better than gas powered engines? Better for the planet. I love that. Not having to pay for gas. Oh man, that's right. The environment, quiet, excellent. Fossil fuels, man, they last long. You are killing it. It could be less money. Man, someone said faster. The acceleration, the torque coming from an electric motor is unbelievable. Quieter. They have iPads. Did you get that, Monica? They do. Inside of them, they have like computers in them. That's really good. Better for energy. Excellent. You're nailing it faster, less pollution, more efficient. Man, you're going to present this for me. Challenge prep, saving money on gas. That's great. Lydia Thompson, sustainable, longer lasting. You don't have to pay for gas, less pollution. Excellent. Riverdale, excellent. DeBow, excellent. Great. Killing it. What about some disadvantages? I don't have a Slido for this. So some of you folks that are in the chat, let me know what are some disadvantages if you are in the Zoom chat. What are some disadvantages that you see to electric vehicles? What do you got? What do you got? I see a new messenger there. What's the new high cost? Yeah, it could be. That's right. You know, the cost of what? The battery. The battery, Riverdale, excellent in Georgia. The battery, what else could be a disadvantage? Yeah, batteries are expensive to replace. You don't really fix them. You got to replace them. Can't go too far. Thank you, PA Leadership Center. Lithium, yes, lithium, this material, how does it impact our environment? Is it really recyclable? I've seen some research that says maybe, climate can be an issue. Thank you, Riverdale. This is excellent. Let's walk through some of these advantages and disadvantages. One huge advantage is a simpler design. As you all, mature as engineers, that's my prayer for you, that you become awesome engineers and scientists. You'll realize that more parts means more opportunities to fail, and gas powered cars have way too many parts. Electric cars is pretty simple: battery, controller, an inverter, and a motor. That's pretty much it. Anthony Akers, excellent answer. That's pretty much it. Simplicity. The other thing that's nice is the cost. You all nailed it when you talked about the cost. When you compare what you can do with $1, you can travel 30 miles with an electric vehicle, but you can only travel about 9 miles with a gas powered car, and that depends on how much gas costs. I mean, it was like $5 a year ago. Come on, Jillian, sheesh. But then also the other nice thing, let me go back a couple slides here. If I could go, let me go back up. I'm progressing. I'm too excited, going too fast. The other nice thing is, for the same price that you use an HVAC unit in your home, you can charge the battery of your electric vehicle. That is outstanding. That's outstanding, right? Other advantages. Burke Central School in North Dakota asks, well, what about weight and what about balance? Well, because they place these huge batteries at the bottom of the car, it allows the car to be more stable. So it has the ability to accelerate more stable out of turns. It has the ability to turn a little more easily because it has a lot of weight at the bottom. That's balance. Think about the center of mass and the center of gravity. Another really nice advantage is we talked about motors. We talked about, placing a conductor in electric field. And when you do that, you use electricity and you convert it to mechanical energy or torque. Regenerative braking flips our minds, flips our brains on that whole process. Instead, if we just allow the motors now, the motors are moving, if we take advantage of the motor moving, the wheels moving, and we allow that to generate electricity, now we're creating energy and putting it back in the system. Well, when does that happen? Well, anytime the electric motor, like when you hit the quote unquote gas in an electric car and it's moving, it has momentum. And because it has momentum, the wheels are already turning, the motor's already moving. Now, as you slow down, you can take advantage of those motors moving and convert that to electricity and power your car. Huge. That's nice. And if we can improve that technology, that'd be a game changer. But it all happens because of batteries. And one of the disadvantages people think about is the range. And so one of the schools hit this, they hit the nail on the head. One of the challenges is electric vehicles. It's not that they don't go as far. They go pretty far. The big challenge is it takes so long to charge. So if I wanted to travel to California from Maryland, which is, probably a 4 or 5 day trip, I would have to stop a lot of times. And while I'm stopping, in the past, these batteries took 12 hours to charge, but that's changed now. Eisenhower High School, great question. What's changed about them is these superchargers they have, not just Tesla, but a lot of different companies have superchargers where you can get down to charging that battery in 60 minutes. That's literally, I can just stop at IHOP and get my favorite pancakes, eat some IHOP.
We don't have them like
Man, I love that engagement. Spot stove school, great engagement. So you probably think, well, what car goes the furthest? That's that Lucid Air, of course. That's that favorite car that I have. And there are a lot of chargers across the world. How you doing, Spot stove? I love those purple shirts. You all are rocking it. So batteries make this happen. It's, lead acid batteries is what we normally use. Nickel hydride, that's what I use.
Hey,
It's lithium ion happen battery chemistry. They got the best chemistry for sure. Energy density, they pack as much voltage and current as you can in a small, lighter weight, as lightweight as the battery can be, lighter weight compartment. They're rechargeable. Those lead acid batteries that are in your car, they're rechargeable, but over time they lose their ability to keep getting charged. They're rechargeable. Their safety is pretty good when you compare it to some other technology that's a little more, combustible. And from an environmental friendliness standpoint, I didn't know this. They are really recycling lithium for sure. They are recycling a lot. So it can be recycled. But mostly what we're looking at right here, lithium isn't the best in all categories, but when you average it out, it gives you the best bang for the buck. And from a cost standpoint, is great as well. So what is happening on the inside? Well, what's happening is we're developing this. What's happening is we have these electrons, right, that as we discharge the battery into a load, into a car, we have ions that are flowing through and closing a circuit with the motor. And that happens, the reverse of that happens where we're charging. So that's basically the physics that are happening inside of it. There's power to a load via electrons flowing through a negative terminal. And on the other side there's a positive terminal, which we call our cathode side. And at the same time, those charged lithium ions go from the negative anode to the positive cathode through this porous membrane that you see right here. And as that continues to flow, we generate electricity to our load. That's what's happening on the inside. And this is the technology you are going to use for the lab today. That's what you're going to be working on. Normally, if this wasn't a special lab day, you'd be working on two things. We'd ask you to, one, create a charging station. We gave you a solar panel to charge in a battery that you would place in an electric vehicle. Then you would charge that battery using a solar panel and place that rechargeable battery inside of your electric vehicle to power an electric vehicle with a very low power battery source, right? And that is the big challenge, low power battery source. But in the interest of time, what we're going to have you focus on today is just what you see in this purple box, developing your electric vehicle. That's the focus for today. And to build an EV, there are a lot of different challenges to build this electric vehicle with a very small power source. I'm showing you some examples right now of some students who use a fan-based source to develop this vehicle. But that's the challenge. Can you fabricate? Can you develop? Can you assemble an electric vehicle with a small power source? And there's a school, Pioneer Technology and Arts Academy and Paul and Jane Meyer Public High School. They asked this question: what's the most challenging part of developing this lab? What's the most challenging part of creating this electric vehicle? So that's my question to you. You can type in the Zoom chat or you can hit this poll. Like, what do you think is the most challenging aspect that you're going to have to create this electric vehicle? Oh man, assembling those parts. She showed me. You got batteries, you may have gears, you got a fan, you got motor, you got your wires, you got your wheels, you got your axles. Yes, coming up with that, like, where do I start? Yes, working in teams. I got a great idea, but Jane has a better idea. Well, like, how do we come together? You know, overcoming the weight and friction, right? Like, you're building this pretty sizable vehicle with a little motor and a little battery. You got to overcome resistance, that friction of motion to get this thing going. That is really, really, really good. I love this part right here, though, that you all are hitting, coming up with an idea, Let me see what you all got in the chat as well. Getting it to move in math. That's really good. Challenge Prep. Shout out to Challenge Prep. Big time ET supporters. Anthony Akers, overcoming the weight and friction. That is excellent. Excellent, excellent. All right. I'm going to give you the secret sauce. I'm going to give you a tool that's going to help you address all of these challenges. And you all know what's coming. You all know what's coming. It is the engineering design process. You can't beat it. You know, this school asks, what are the best ways for students to approach designing the electric vehicle? It's this big wheel right here. This is the wheel. If you could just put this wheel on your electric vehicle, you'd be rolling, no pun intended. I'm full of dad jokes today, I'm sorry. The engineering design process, where you start with your imagination, and in your imagination, you're not limited to what just you have in your mind. You know, you have your team that you can do some research together on the internet. You can look at DIY electric vehicles. You can look at how to assemble cars. You could, how do I reduce friction? How do I get the most power out of a small motor? You can research mechanical advantage. There's all these different things that you can research before you design. And then, like, what's the best approach to designing? I like to design on a sheet of paper for sure. I mean, I want to make this design come to life on paper and talk about it with my team. We even do this with satellites before we ever build it, because if we build it before we design it and really think about it, we could build the wrong thing. We could build the wrong thing. And then after we build it, you got to test it. Like, we got to test it multiple times, over and over again, until you get the right design, until finally you deploy it, So we gave you a bunch of different parts. You got your propeller. That's one way of moving that car. You hook up the propeller to the motor and through the thrust, right? Thrust and Newton's laws, right? You get this vehicle to move. I think it's Newton's third law. For every action, there's an opposite and equal reaction. You can use Newton's law in air, right, to move this vehicle. And then you have a battery. You need the battery and closing that circuit. You hook up the motor to the wires and the battery, you close the circuit, electrons get to flow, and that's how the motor gets to spin. You place that battery in a battery holder, which we've given you, which already has some of those wires to make it a little easier for you. You're probably wondering, what do I do with this axle? Well, I hook up my wheels and I place that on the axle. All that stuff comes together. Then you have your gears and your pulleys. Hey, I'm showing you pictures. I want to show you the real deal. Hey, look at this. Look at that. Hey, give me a thumbs up. Can you see my two electric vehicles? Somebody let me know in the chat. Do you see electric vehicles that I've manufactured and messed around with. Oh, thank you, Jillian. So here, this is what I'm talking about with this little motor that you get. You can get to spinning. That's one way. Thank you, Southwestern. That's one way. But even look at this. Here's another way. I got this motor right here. I have this pulley, and I can transfer the motion. This is direct transfer. Whereas Dr. Eric, he also talks about direct transfer from the motor to wheels in order to get it to move. Look at that. Look at that. And why do I have these straws? Like anybody, why do I have straws on this design? This is important. Anyone can tell me why I have straws? Hey, Caleb, Nav, why do I have straws around these axles? Why is that important? Why the straws? What are they doing for me? Anybody? Why are my straws? Teachers type in the chat. Thank you, Monica. This is, we're spending a little more time here with you all on how to develop so the wheels can move. Thank you, Challenge Prep. When we talked about resistance and friction, you know, we reduced the friction. We gave you some little black straws in this bag, and if you place those around an axle, it's going to reduce that friction. Because if we just tape or glue the axle down to the body, it won't move. Yes, that's right. To help them spin. Excellent, Carver. That's excellent. That's good. Okay, great. What do you think are going to be some challenges? What happens if this little pulley that I have is too loose? Let's say you have this pulley design and you develop the pulley design where, it's like a flywheel. I have a wheel on my motor. I have a wheel on the axle. What if the pulley is too loose? What's going to happen to my ability to help this car move? That's right, the wheels won't spin. It won't transfer torque. Thank you, Diboll High School. So you got to think about that. It can't be loose. But what happens if it's too tight? Like what happens if it's stretched out and it's too tight? What do you think will happen if it's too tight? And then we'll move from this pulley. We'll talk about the gear design. What do you think, Diboll? That was an excellent answer. If you want to come back, that's right. It could be a waste of energy because now I'm just creating too much friction. That is excellent. Too much friction. And the energy is being transferred into the action of friction and not into the action of motion. Excellent. All right, let me get this car out of here. How about this one? This is challenging. What do you think is really challenging when you have a design that includes gears? Like, what do you think? Like, man, what do I gotta do to figure this thing out? How do I develop a design with gears? What was your mind is thinking about this problem? How are you thinking this needs to work out? What are you thinking? I'll give it a little time. We got a little time. I'm just trying to spark, Jillian, Monica. Gears have to fit perfectly. Yeah, buddy. You are cooking in hot grease. They got to fit because if they're misaligned, if I just misalign them a little bit, I won't make contact between both of these gears and it won't move. They have to align. You got to think about making a design that ensures that those gears align, that they make good contact, right? That they're not like if you glue them down, they're not slipping. You got to really think about even just the glue, the location. Excellent answer. I don't know who's that. And I got to give you some props. Yes, Challenge. The gear ratio. Excellent. Riverdale, yes. Think about this as you're making this design. You all are, hey, we're ready to do this. All right, we're ready to do this. Here's some general designs. We're talking about research, learning. We're starting your research process right now. Here are some general designs that you can take advantage of. Think about the cars. We've given you some wheels. Think about where you're going to place your battery. Are you going to use cardboard? A lightweight material like cardboard. Are you going to use a bottle? A lightweight material such as a bottle. Where do you place your fan? If you're going to go with this air-powered design, excellent, right? That's all good stuff, right? And I'm showing you right here just an example of a little car, a little vehicle that I developed in my home a little while ago. Look at that, buddy. That little thing is picking up some speed, but friction and mass, all of that stuff was really important. It even nailed the bump. I mean, it had enough power to nail the bump and it's still going. That's an example of a design, right? But you're thinking, hey, Milton, man, I don't know. That's not really fast. All right. Well, you need a little more speed. Maybe you could take advantage of using multiple batteries. You know, as you grow in your electrical engineering knowledge, you'll learn that if you bring batteries together, you can either increase the voltage, right? How much electrons you're pushing, more voltage. You could go from like let's say this is a 1.2 volt to a 2.4 volt. If you place them in series, you double the voltage, pushing those electrons. Or you can increase the current. You're opening up electrons to flow more electrons to flow at one time. All of those have different benefits on how you develop your vehicle. That's one way of making it fast, right? I'm demonstrating right here a couple of vehicles that I made. You saw an example. This is the pulley-based design, you know, getting a little speed, and that's just with one battery. And this here is the gear-based design, right? A little bit more speed. I'm gonna close a circle on this bad boy. Look at that. Oh, oh, oh. Oh man, we're cooking. Can you make a car? That's the challenge. Can you make a car faster than my car? I wish we were in person. We could have a little challenge. The way that all happened was through mechanical advantage. We increased our acceleration, or you can increase your speed through a mechanical advantage. And we did that through gear ratios. And one thing you notice, think about this. Do I have a small gear on the motor, or do I have a large gear on the motor? You see the small gear. And man, if you could wrap your mind around this, the reason we have the small gear is because our problem is we got a big car and a little motor. So I don't necessarily need, you know, speed. I need to get this big car to move. And I can do that by gearing up, by ensuring that this motor turns less times, right, than the gear that's on the axle, so I can have more power. Think about that when you're making your design, all right? And that's all mechanical advantage, which we have some great charts in here for you to work through. So as you continue to explore this, you know, if you enjoyed this, I don't want you to think about developing an electric vehicle as just the motors, right? And just the speed. I want you to think about, you know, designing a car. Maybe you're someone that loves design. You're an artist. Even designing the body of the car, making it aerodynamic can help us develop sustainable vehicles, less resistance, right? Think about the design. Think about energy storage. Like maybe you don't like the vehicle, but you know, batteries, in order for them to keep working appropriately, they have to be stored mostly in cool temperatures. How do we store them? You know, you may be the type of designer that designs, you know, the logistics and designs these buildings and things to store them. It's solar energy. You know, how do we take more advantage of solar energy? Increase its efficiency. If you're a chemist, right, you can help us increase the efficiency of these photovoltaic cells. So we get more than just 30% efficiency. If we could get 60, 70% efficiency, we may be even just to use solar energy directly with our cars. And there's some companies that are doing it. And then just, you know, if you loved all that, maybe electrical engineering is what you're going to enjoy. This bringing together the circuit, the power, the electricity. Maybe it's mechanical engineering. That's the design, that's the torque, that's the power, all that good jazz. Maybe it's materials. How do I make lighter materials to make this vehicle, you know, transport faster? And then the systems engineers that bring it all together. Excellent, excellent, excellent. Well, if you enjoyed this, I do want to give a shout out. We're going to have an electric vehicle competition Saturday, May 18th. You got your vehicle. If you're in the DC, Maryland, Virginia area, you can come and check us out. You can sign up for this vehicle. We got some awesome prizes for people that come together for this electrical vehicle competition. We want to see you there. You may even see Monica there in person, which is just unbelievable, the energy that she's going to bring. You may see my buddy Jose as well. That's Saturday, May 18th, and you can sign up using that QR code. And with that, I just want to say, let's go. Let's do this thing. I'm going to hand it back over to Monica to talk about next steps. I hope that you are revving your engines. Back to you.
100%. I want to just give a round of applause for Milton for that amazing introduction. I hope everybody is revved up and ready to roll with building your EVs. And we are going to open up the breakout room so you guys can get